summer camp. This is my fifth video on acids and bases. In this session, we are going to learn some important chemicals and their uses. At the same time, we also learn the water of crystallization with a lab activity. See, we are going to learn baking soda and its uses. How do we prepare baking soda? Next, washing soda and uses of washing soda. The third one is the plaster of Paris. Plaster of Paris. The fourth one is water of crystallization. We will learn all these things in detail one by one. Baking soda. Its chemical name is sodium hydrogen carbonate. This sodium hydrogen carbonate is prepared by sending carbon dioxide and ammonia gas through aqueous solution of sodium chloride. When aqueous solution of sodium chloride, from that solution, when we pass carbon dioxide and ammonia gas, we will get sodium hydrogen carbonate, or we call it as the baking soda. See, here is the equation. Aqueous solution of sodium chloride, carbon dioxide gas and ammonia gas is sent into the aqueous solution. You will get sodium hydrogen carbonate or baking soda. Not only that, ammonium chloride is also formed, but we do not consider this ammonium chloride. Now we will study the important uses of baking soda. So baking soda is used in making baking powder. What is a baking powder? Baking powder is a mixture of baking soda and a mild acid like tartaric acid. This is known as the mixture of baking soda and tartaric acid is known as what we call it baking powder. So while preparing the cake, when we heat the mixture, the composition of the cake, along with this baking powder, the sodium hydrogen carbonate or baking soda present in it loses water molecule and carbon dioxide is liberated. See this one. Here, when sodium hydrogen carbonate is heated, that is baking powder is heated, see it gives sodium carbonate and water molecule and carbon dioxide. This carbon dioxide produced during the reaction causes the bread and cake to rise and make the cake and bread soft and spongy. Carbon dioxide here on heating the mixture of that is what we call it baking soda and tartaric acid along with the ingredients of cake. See, when you heat, carbon dioxide gas is produced. This carbon dioxide gas causes bread and cake to rise and make the cake and bread soft and spongy. The cake and bread becomes soft and spongy because of this carbon dioxide gas produced always tries to escape from the tiny holes, making tiny holes. That's why the cake and bread is spongy and soft. Next, second one, this baking soda is used in the preparation of antacid. It is one of the important ingredients in antacid. Next, the third one is it is used in soda acid fire extinguishers. Soda acid fire extinguishers. See, this soda acid in the sense, see this one. This is baking soda and sulfuric acid. These two are present in fire extinguishers, soda acid fire extinguishers. When you hit the knob, this sulfuric acid reacts with sodium bicarbonate or sodium hydrogen carbonate and it put off the flame. Carbon dioxide gas is produced and water also produced and fire is brought into control. Next, the second important one is washing soda. See this one. In our earlier equation, we studied on heating sodium hydrogen carbonate. Sodium carbonate is produced and carbon dioxide and water molecules are also produced. Sodium carbonate is prepared on heating baking soda. Baking, on heating baking soda, what is produced? Sodium carbonate is produced. Recrystallization of sodium carbonate gives washing soda. See this one. This is known as recrystallization, means water molecules or 10 water molecules are added to sodium carbonate. So this sodium carbonate decahydrate Na2CO3 10H2O is the formula of washing soda. Next, what are the uses of this washing soda? Washing soda is used in glass, soap and paper industries. It is used in glass, soap and paper industries. The second one is used in the manufacture of sodium compounds such as borax. It is also used in the manufacture of sodium compounds such as borax. It is used as the cleaning agent for domestic purposes. Next one, it is used for removing permanent hardness of water. So the next important chemical is plaster of Paris. Plaster of Paris is prepared on heating gypsum. It is prepared on heating gypsum. That is CaSO4 2H2O is known as what we call it gypsum. When you heat this when you heat this gypsum at a temperature of 373 degrees Kelvin, here 373 degrees Kelvin means 100 degrees Celsius. When it is heated to 100 degrees Celsius or 373 Kelvin, it loses water molecules partially to become calcium sulfate hemihydrate. See this one. When you heat gypsum CaS4 2H2O, it loses 1.5 water molecules and you will get calcium sulfate hemihydrate. This calcium sulfate hemihydrate is known as what we call it a plaster of Paris. Plaster of Paris. See this equation. When gypsum is heated at a temperature of 373 degrees Kelvin or 100 degrees Celsius, you will get that is a plaster of Paris CaSO4 of H2O. This is known as what we call it calcium sulfate hemihydrate, which is also known as plaster of Paris. What are the uses of plaster of Paris? Plaster of Paris is used by the doctors for supporting the fractured bones. Orthopedic doctors uses for supporting the fractured bones. It is also used for making toys, materials for decoration and for making surfaces smooth. Fall sealing in the construction field, we use this plaster of Paris to make the surfaces smooth. Observe the formulas of few salts. Sodium carbonate 10H2O. Next, CaSO4 half H2O. CaSO4 2H2O. Next, MgSO4 7H2O. MgCl2 ACl 6H2O.
As a part of the experimental science, see how to score more marks related to lab activities. Okay, see this is the fourth question. What is that? Water of crystallization. How will you remove the water of crystallization from the salts? Okay, స్ఫటికీకరణ జలాన్ని మనం ఏ విధంగా తొలగిస్తాము? ఇంతకుముందు పబ్లిక్ ఎగ్జామ్స్ లో నెంబర్ ఆఫ్ టైమ్స్ రిపీట్ అయినటువంటి క్వశ్చన్. ఓకే, సో ఫస్ట్ ఆఫ్ ఆల్ యూ హావ్ టు రైట్ ద మెటీరియల్స్. What are the materials needed?
That are associated with one formula unit of a salt.
First one I will show one by one. So, this is copper sulfate. What is the color of copper sulfate? Blue color. Okay, copper sulfate crystals are blue in color. Okay, we don't know water is added here. Okay, this crystal is associated with some number of water molecules. Okay, so those number of water molecules that are associated with the formula unit of one formula unit of a salt is known as water of crystallization. What we call it? Water of crystallization. How can you remove the water of crystallization? See this one. First I have taken copper sulfate and another one what I need? A boiling tube. This is known as the, what is that? Boiling tube. Okay, next test tube holder. Like and share and subscribe. See, I am writing the materials here. First one by one I will show you. What are the materials? First copper sulfate. Second one boiling tube. Third one, watch glass or china dish. Next one, this is nothing but, what is this? This is a spirit lamp and a matchbox. Spirit lamp, lamp, and the last one is matchbox. So don't by heart the process. Listen to me. First you take boiling tube. First you switch off the fan. Switch. See, I have taken boiling tube. I hold the boiling tube with the help of the test tube holder, and now I am taking few crystals of this is known as spatula. What we call it? A spatula. What is the color of this copper sulfate? Blue color. Okay. You keep it aside. Hold it. Right. Now lit the spirit lamp. Lit the spirit lamp. What I am doing? I have taken copper sulfate crystals in the boiling tube. Okay, you have to observe the changes that are taking place. Okay, you must be very careful. See this. The color of copper sulfate is blue in color. Okay, copper sulfate స్ఫటికాలు ఏ రంగులో ఉన్నాయరా? బ్లూ, నీలి రంగులో ఉన్నాయి. ఏమవుతుందో చూడండి. హీట్ చేస్తున్నాను. You will find the water droplets on the walls of the test tube. Observe this carefully. Do you find the water vapor? Some water vapors are produced. Observe this one. Means this crystal, this salts consists of, what is that? Water molecules. What is that? Do you find the water vapor? Do you find any change in its color? Actually, initially it is blue in color. Gradually, observe this carefully. It changes to white color. Observe this. Okay, it is changing to white, and if you observe carefully on the walls of the boiling tube, you will find water droplets. Water droplets, because this crystal salt, that is copper sulfate, is associated with 5 water molecules. On heating, these 5 water molecules are removed. 5 water molecules are removed. Give me a paper, one white paper. Fold it, fold it, fold it. Observe this carefully. Water molecules are formed on the walls of the test tube. You observe this very carefully, because water molecules are removed. Now, I am transferring the contents. See this, give me one more paper. Give me one paper. One more. Give it to me. Give to me. See this? What is the color? White color. Now, observe this. I am adding water to it. What happened? What happened to this one? It regained its original color. Okay. The color is because of the number of water molecule associated to it. Once it is heated means the water molecules present in it are removed. When I add the water, okay, it regained its original color. Are you clear? So with this experiment, we can say that copper sulfate salt consists of water molecules. It is associated with water molecules. Those number of water molecules present along with the salt, one formula unit of a salt is known as water of crystallization. So with this experiment, we can conclude that how to remove water of crystallization. Okay, are you clear? No need to by heart anything, బట్టి పట్టాల్సినటువంటి అవసరం లేదు. Okay, what you observed you write in the examination. Okay, are you clear? No materials, no need to by heart the materials, test tube and all those things. Okay, simply I did the experiment in front of you. What you have seen, what is the procedure I followed, you write the same and produce it in the examination. Okay, it brings you 8 marks. Okay, right, close it.